Again, here we go. I've got a triangle. It told me what side C, side A, and angle gamma are. So let's draw ourselves out a nice little triangle here. I'm going to make this big angle gamma, so that's 102 degrees. That means this side opposite that has to be 51.6. I don't know, what do you want me to make? I'll make this angle alpha, because the side opposite that has to be 42.1. And I'll make this side angle beta, so the side opposite that has to be side B. Alright, the law of sines tells me that if I take the sine of gamma, 102 degrees, and you don't need those parentheses. In fact, I'll stop writing those right now. So sine of 102 degrees over the length of the side opposite that, 51.6 units, is equal to, let's see, sine alpha divided by the length of the side opposite that, 42.1 degrees. And again, 42.1 units. And again, I will solve this with cross multiplication. So I'm going to say that the sine of alpha is equal to 42.1 times the sine of 102 degrees divided by 51.6. Now I'll just pop that into my calculator. So sine of alpha turns out to be 0.798062286, I think is what I've got. So alpha is equal to the sine inverse of that same number, 0.798062286. And that gets me a nice answer. So alpha has got to be, well, my calculator tells me it's going to be 52.945 something something something. I'm going to round that off to 1/10 of a degree, so I'll say it's 52.9 degrees. That is alpha. Okay, so I'd like to find the other angle, angle beta. I need more room, so I'm switching to another page. But I know that all three angles of the triangle have to add up to 180 degrees. So beta will equal 180 minus what the other two angles were. So minus, let's see, minus gamma, that was 102 degrees, minus alpha that we just solved to be 52.9 degrees. Now that's going to give us 25.1 degrees. So I now have all three of the angles. I was given two of the sides, but I need the other side. I need side B. So here's what I'll do. I'll use the law of sines a second time. I can't use a Pythagorean theorem because it's not a right triangle. So I'll say the sine of 102 degrees divided by that length of the side opposite that, 51.6, should be equal to the sine of beta, because I just found that out, 25.1 degrees, divided by the length of the side opposite that, we'll just call it B. And again, I'm going to use cross multiplication. So B is equal to 51.6 times the sine of 25.1 degrees divided by the sine of 102 degrees. B is going to be, when I put that into my calculator, B is going to be 22.3777 something something. I'm going to round it off to 1/10, so 22.7 units. That's what B is. Okay. Now, some of you are going to be saying, well, how do I know that that's the only solution? How do I know that there's just one solution? Well, we have to go back and remember, when I solve for alpha, I've got 52.9 degrees. Now, the problem is that when we use our calculator to find the inverse, it gives us what's known as the reference angle, right? But the reference angle for sine inverse is anything in the first or second quadrants. So it could be 52.9 degrees in the first quadrant, or 52.9 degrees in the second quadrant, because that's where sine is positive, right? Okay, well, if it was the angle in the second quadrant, we have to measure that from the x-axis all the way over. So that second angle should really be 180 minus 52.9 degrees, which is going to get us 127.1 degree. Now, if we say that's what alpha should be, is 127. Oops. If we say that alpha is 127 degrees, 127.1, then when I add gamma plus alpha, gamma was 102 degrees, alpha we've just solved to be 127.1 degrees. When I add those together, I get 229 degrees, well, 229.1 degrees, which is more than 180. So it's not possible to have those angles in a triangle. So this one only has one solution. One solution could not be 127.1 degrees. All right, let's go on to a third and final example of the law of sines. This one I have B is 9, A is 7, and alpha is 20, so let's draw ourselves out a nice little triangle. And I'm going to change colors back to black. All right, so for no apparent reason, I'm going to make this angle alpha. There's 20 degrees, so the side opposite that has to be 7 here. I'm going to make this guy beta, so the side opposite that is 9. That leaves this angle as angle gamma, and the side opposite that is angle C. So again, I'd like to find, in this case, I'd like to find beta. So I'm going to say the sine of alpha, which is 20 degrees, divided by the side opposite, that's 7, is equal to the sine of beta divided by the side opposite, that's 9. And again, I'll use cross multiplication, so I'll say the sine of beta is equal to 9 times the sine of 20 degrees divided again by 7. So sine B, or sine beta, is going to be equal to approximately 0.4397, I think that's 0.1843, something like that in my calculator. And again, if you're not getting those numbers, check your calculator. You need to be in degree mode. So beta is equal to the sine inverse of that same number. I plug that into my calculator and happily get a nice angle. Beta is going to be approximately, well, when I put it in my calculator, I get 26.087 something something something, so I'm going to round that off to the nearest tenth of a degree and make it 27 or 26.1 degrees. There's my beta. I'd like to find gamma, but that's not a problem. Let me get to the next page. Gamma should be 180 minus alpha, which was 20 degrees, minus beta, which we said was 26.1 degrees, which will wind up with 133.9 degrees. So we just found gamma, it's 133.9 degrees. Now I can find the side opposite gamma, that's C, and I'll do that in practically the same way with the law of sines. I'm going to say the sine of alpha, which was 20 degrees, divided by the length of the side opposite, that's 7, equals the sine of gamma, which we said was 133.9 degrees, divided by the length of the side opposite, which we'll call C. So I'll solve by cross multiplication. C will be equal to 7 times the sine of 133.9 degrees divided by the sine of 20 degrees. I'll get you in my calculator, I'll get C is equal to 14.747 ... So I'll round off the nearest tenth and say C is equal to 14.7 units. There we go. I've solved for C. Now, let's take a look back. At the very beginning, we said, when we solved this guy, we said beta was 26.1 degrees. Well, again, that could have been 26.1 degrees in the first quadrant, or 26.1 degrees in the second quadrant, because sine is positive in both quadrants. So I'd have to measure from the x-axis all the way over, which would mean beta could also be 180 minus 26.1, which turns out to be 153.9. Now in the previous example, when we added the angle they gave me plus this second angle, it added up to more than 180 degrees. Well, it doesn't in this case. So now I can find angle gamma by saying 180 minus angle alpha, which was 20 degrees, minus angle beta, which I now say is 153.9 degrees, and I can get a new gamma, and my new gamma will be 6.1 degrees. So I now have a new gamma, and now I need to find that new new side C, but I'll do that in just the same way. I'll take the sine of alpha, which was 20 degrees, over the length of the side opposite alpha. That should equal the sine of gamma, but in this case, I'm going to use the 6.1 degree over C. So C will equal 7 times the sine of 6.1 degrees divided by the sine of 20 degrees. And when I plug that into my calculator, I'll get about 2.174 ... So C is approximately equal to 2.2 units. So there we go. I have a different measurement for beta, and once I get that different measurement for beta, it gives me a different measurement for gamma and for the side C. So this is an example of a triangle that has two solutions when trying to solve it by the law of sines. All right.